Advanced Algebra, Chapter 8, Lesson 2, and we're going to look at the graphs of exponential functions and applying transformations to those graphs. Now, you remember we did this earlier in the year, and we just recently did this with the radical graphs when we did cube roots and square roots, and we have the horizontal shifts to the right or to the left. We have the vertical shifts up or down. We have the vertical stretches where we multiply the function by a value, and then we have the reflection over x where we have a negative sign. All of those transformations again apply to the exponential graph, and so we're just going to jump right in and do a few examples. There is one thing, however, that we want to add that we haven't done with the other graphs, and that is determining the y-intercept. Now, the y-intercept is where the graph will cross the y-axis, and the important thing to understand about this is where the x value is 0. So when we substitute 0 into the equation, the value that's produced is where that is going to cross the y-axis. Now, the point we already know, 0a, is on the graph, so that actually is the y-intercept. Now, if we have a horizontal shift to the right or to the left, that point gets moved off of the y-axis. And so there's going to be an additional point that I want you to determine, and that is the y-intercept when we graph this. So if there's a horizontal shift to the exponential function, and the point 0a is moved either to the right or to the left, we want to substitute in the value of 0 for x and then determine where the graph will cross the y-axis. And that's going to help us get the shape of these exponential functions. So let's take a look at a few examples. So we'll do one example where we have an exponential decay, and here we want to remember that we want to graph the asymptote, and we want to graph the point 0a as part of the first initial steps that we do. So the 0a and then the line y equals 0 is our asymptote. Now, before we start jumping into all of that stuff, we want to take a look at the equation and get in our mind a mental picture of what's going to be going on based upon what we know. So I look at the equation here for number 1. I see it's an exponential function because the variable is part of the exponent. I see that the b value is a number or a value between 0 and 1, which means that this is going to be a decay. So I realize that this is going to come down as we move to the right. There is no shift right or left, so that's not going to affect the point 0a or the y-intercept, and there is no shift up or down, so that's not going to affect my horizontal asymptote. So when I get done, my graph should generally look like that. Now that we know that, let's go ahead and graph this. The point 0a is on the graph, so a here is the number 3, so the point 0,3 is on my graph, so I'm going to go ahead and graph the point 0,3, and then I'm going to label that point. The asymptote is not moving, so the asymptote remains at y equals 0, so I'm going to put that in here and label the asymptote. Now again, I know this graph is coming down and decaying or getting smaller, so on this side of the point 0a, it's going to get closer and closer to 0. The only question is, how does this climb up over here? And actually, I probably drew that just a little too sharp because I don't know how this is going to climb. I don't know if we're going to come up very sharply or if we're going to go out here kind of slowly. To find a point, then, I'm going to substitute in a value to the left. I usually like to go 2 places over because that gives me a fairly good picture. So I'm going to substitute in the value -2 for x and determine what that value is. So substituting in -2 to the equation, then I have 3 times 1/2 to the -2 power. The -2 power, in order to make that positive, I need to switch the values of the fraction. Meaning, if I distribute, or not distribute, but if I raise each of these values, they're both going to be to the negative power, the 1 and the 2, the numerator and the denominator. To make those positive, I would move the numerator to the denominator and vice versa, making the values positive. So basically what I can do is I can reverse the fraction inside first, that changes the exponent to a 2. 2 squared is 4, and then that number times 3 is 12. So when I substitute in -2 for an x value, I get a y value of 12. So over here at -2, I plot the point -2, 12. Now I can see how this graph is climbing, or decaying actually, as it comes down through the point 0a, and then this climbs up this way. Sorry for that little squiggly. It gets pretty tough when I'm drawing on my pad here, trying to get that to climb or to decay. So this would be the graph of the function. So again, we want to get a mental picture before we start. If 0a, we need to locate that and then apply our shifts and transformations, and the same thing with the horizontal asymptote. In our next example, number 3, again, I want to get a mental picture of what we're doing. I see it's an exponential equation because the exponent contains the variable, which means I'm going to use the point 0a as a reference, and I'm going to use the line y equals 0, my asymptote, as a reference. Because there's a value being subtracted from the x variable, that means that's a horizontal shift, so x minus the shift, so this is my shift. So this is a 2, a positive 2, so I'm going to add that to the point 0a, or to the x coordinate of 0a. So 0 plus 2 gives me a 2. The a value is a 4, so I have a point labeled or plotted at 2, 4. So I can go ahead and plot that 2, 4. I see that this is a 2, the value is larger than 1, so this is going to be a growth, so I know that the function is going to grow as it goes this way. So I'm going to use that just to label this point over here, just to keep it out of the way. Now there is no vertical shift up or down, so that means my asymptote y equals 0 is going to remain at the line y equals 0. Now because this a value has been shifted to the right 2, I want to find out where this is going to cross the y-axis. So I'm going to substitute in the value 0 for x and simplify the expression to find out where this is going to cross the y-axis. So substituting in 0 for x here, 0 minus 2 gives me a -2. So that means I'm going to have 4 times 2, I didn't need to put that there, 4 times 2 to the -2. Now 2 to the -2, I need to change this exponent so it's positive in order to deal with it. So this is going to be 4 over 1 times 2 squared. Now 2 squared is 4, so because I'm multiplying these, the 4's reduce, which gives me a value of 1. So when I substitute in the x value of 0, I have a y value of 1, so that tells me this is going to cross the y-axis at the point 0, 1. So because it's a growth, then I know that this has to come through here and it's going to grab here, so I have a fairly good picture of how this is going to grow. I can just extend that out. So sometimes by determining what the y-intercept is, I get a pretty good picture of how this is going to grow in that way. Let's go ahead and look at number 8 here, and again I want to go through kind of a mental process of determining what kind of shape I'm going to have before I'm done. That way I have something to check. So I realized that because the exponent contains the variable, this is an exponential function, so I'm going to use the point 0a and the line y equals 0 as my reference points. This 1 out here tells me that everything's going to be shifted up 1. The 1 here tells me everything's going to be shifted to the right 1. The 1/6 tells me that this is a decay, so I realize that this is going to be shifted up 1 because of that, and it's going to be decay, and so it's going to look something like this when I get done. So now that I've done that, let's start applying some of our transformations. So the point 0a is on the graph. In this case, a is a third, so the point 0, 1/3 is on the graph. So let's apply the transformations to this point and then the asymptote. The +1 is going to add 1 to every y value. So my y equals 0 is going to now be y equals 1. So my asymptote here is at y equals 1. So make sure that we put that on there, and then make sure that we label that. So this is at y equals 1. Now, because it's shifted up 1, I'm going to add 1 to the y value. So this y, this 1/3, adding 1 to that is going to be 1 and 1/3. Okay. Now, there is a horizontal shift of 1. We're going to add 1 to each of the x values. So this is going to be 1. So I plot the point 1 and then 1 and 1/3. Now again, this is getting close to the y, the asymptote over here, so I know that this goes like this. Now because this is coming down rather sharply, or it could be, we want to go ahead and determine what the y-intercept value is, so we're going to substitute in the value 0 to determine that. So substituting in 0 for 1, or x, excuse me, 0 minus 1 is -1. So that's going to give me 1/3 then times 1/6 to the -1 and then plus 1. In order to make this negative exponent, or applying this negative exponent to this, both of these are going to be to the -1 power. Switching places, I can make it a positive, so this is going to be 1/3 times 6 plus 1. Reducing this then gives me 2. 2 plus 1 is 3. So the y-intercept value is 3. So that tells me that this is going to cross the y-axis at that point there. Now I have a pretty good idea that this is rising pretty sharply, so I can go ahead and just draw that in there, and then I have my graph of this exponential decay graphed.